In this video we are going to see how to find the derivative of e to the power x. Here in e to the power x, the base is e, which is a mathematical constant, and the power is x, that is variable. Okay, whenever we find derivative of a function in which we have variable in exponent, what we need to do is we have to use logarithm. So that is, before we find derivative of such a function, we have to take logarithm on both sides. In calculus, in differential and integral calculus, always we use natural logarithm. So we can take natural logarithm on both sides of this function y is equal to e to the power x. My aim is to find the derivative, that is dy over dx I have to find. So now I am going to take natural logarithm on both sides of this function, then I get ln y is equal to ln e to the power x. Okay, here on the right side we have ln e to the power x. So what we can do is we can use the power rule of logarithm, that is, whenever the argument of a logarithm is exponential, we can move this exponent in front of the logarithm here. So then we'll have x times ln e. Here in this function we have logarithm on both sides. Both the logarithms are natural logarithms. We already know that the base of a natural logarithm is e. Since it is a natural logarithm, so the base of this logarithm is also e. Here in this logarithm, both base and argument are same, that is e. In any logarithm, if the base and argument are equal, then the value of such logarithm is 1. So the value of this logarithm is also 1. So in the next step, we'll have ln y is equal to x times 1. So we get ln y is equal to x times 1 is just x. Okay, that's all the simplification we can do using the power rule of logarithm. Now we can start finding derivative. Here ln y is equal to x. Okay, so here I told you already that we have to find dy over dx, that is, we have to find derivative with respect to x. When I find derivative of logarithm, I have to take 1 in numerator, and in denominator I have to take argument. Whatever argument I have here, the same should be taken here. So far I have completed derivative only for the logarithm. Now by chain rule I have to find the derivative of this argument y with respect to x. So the derivative of y with respect to x will be dy over dx. Okay, on the right side, when you find the derivative of this x with respect to x, it will be just 1. Okay, now what we can do is, actually my aim is to get dy over dx, so I don't want this 1 over y. So to get rid of this 1 over y, I need to multiply both sides by y. So this y will cancel out, we get dy over dx is equal to y. Already we know that y is equal to e to the power x. So y can be replaced by e to the power x. So now it's clear, the derivative of e to the power x is the same e to the power x. We can explain the derivative of e to the power x using chain rule. Okay, just now we got the result that the derivative of e to the power x is the same e to the power x. Okay, let's consider the function y is equal to e to the power x. So now I am going to find derivative on both sides with respect to x. Then I get dy over dx is equal to the derivative of e to the power x is same. Okay, when we approach this one using chain rule, that is, the derivative of e power x is, we are writing the same e power x. So far we have completed derivative only for e to the power x. By chain rule, you have to do further derivative of the stuff what we have in exponent. So when you find the derivative of the exponent x with respect to x, it will just be 1. Then e to the power x times 1 will be e to the power x. Finally dy over dx is equal to e to the power x. Okay, we can do the same approach when we have some other different exponent instead of x. Okay, let's consider y is equal to e to the power mx, m times x, where m is a constant. Now I find derivative on both sides, so with respect to x. When I find derivative of y with respect to x, I get dy over dx. On the right side, when I find derivative of this e to the power mx, the same. Okay, now by chain rule, you have to find the derivative of the stuff what we have in exponent. So now the exponent is mx. When you find the derivative of this one, the constant m to be kept as it is, you have to find the derivative of this variable x with respect to x, which is 1. So m times 1 will be just m. So now I got the derivative of the exponent, that is m. So finally dy over dx is equal to m times e to the power mx. Let's look at another example. Consider y is equal to e to the power minus x. I find derivative on both sides with respect to x. So on the left side, when I find derivative of this y with respect to x, I get dy over dx. On the right side, when I find derivative of e to the power of minus x, will be the same, e to the power minus x. So by chain rule, I have to find the further derivative of the exponent negative x, it will be negative 1. So dy over dx is equal to e to the power negative x times negative 1 will be negative e to the power negative x. Okay, let's look at another example. Y is equal to e to the power x square. So now let's find derivative with respect to x, then we get dy over dx on the left side. When I find derivative of e power x square, I will be getting the same. So I have to do the further derivative by chain rule. I have to do the further derivative of the exponent x square. So the derivative of x square is just 2x. So the final answer is dy over dx is equal to 2x times e to the power x square. Let's look at one more example to have better understanding of this stuff. So consider the function y is equal to e to the power of x to the third power positive 3x square negative 5x negative 2. Okay, now we find derivative on both sides with respect to x. We get dy over dx on the left side. On the right side, when I find derivative of e to the power of something, the same I have to write. So that is e to the power x cube plus 3x square negative 5x negative 2. Further, by chain rule, I have to find the derivative of the stuff what I have in exponent. So here I am going to find the derivative of this one, then I get 3x square positive, the derivative of this 3x square is 6x, and the derivative of negative 5x is just negative 5, and this is a constant, it will become 0. So the final answer is dy over dx is equal to 3x square positive 6x negative 5 times e to the power x to the x cube plus 3x square minus 5x minus 2. I think this video will be much helpful for the students who study calculus. If you like this video, please subscribe our YouTube channel. Thank you all.